All right, so this is video number 2 for chapter 9.2. So this is still new content. So on the last video, I talked about limiting and excess reactants. So when you're determining a limiting and excess reactant, you only consider the reactants, you don't consider any of the products. So we're just going to build upon our last lesson and take it to the next step. So pretty short lecture today as far as examples. Okay, so on Monday, you should have watched the first video on chapter 9.2 and you should have completed this problem. So if you go back to your notes from the other day, you should have this problem done. Okay, so we first balanced it. Let me get my black pen. Okay, and then we did the comparison between the iron and the water to determine which was a limiting and which was the excess. So if you go back to your notes, hopefully you followed along. If you started with the iron, you would have found that we needed 71.8 grams of water. So we need about 72 grams, but we only have 36. Therefore, water has to be our limiting. If you did it the other way, if you started with 36 grams of water, you would have found out that we needed about 84 grams of iron. We have 167, we only needed 84-ish, so this is going to be our excess. So I like to write above the reactant which is which. Okay, so we're going to continue this now. What do? We now know which is which. What do we do now? Okay, the next step is to use the limiting reactant to determine the unknown. Okay, so we're taking this a step farther. So your unknown is going to be the hydrogen as the product. Okay, so if you see a problem like this, let me erase the font. Okay, if you see something like that, okay, you still have to determine which is which as far as limiting versus excess. Then you're going to use the limiting to determine the unknown. Okay, so once again, let me write this back in. So don't let it confuse you when you have two given numbers and a question mark. You still follow the steps that we're doing. So the first step is to determine which is the limiting, which is the excess. Okay, now that we know that, I'm actually going to cross out excess because I don't need it. This is the only number I'm concerned with, and the only thing I'm worried about on this side is my unknown. So I don't even care about this. If you want to cross it off, that helps you do whatever you got to do. Okay, so now I'm going to do a simple mass to mass. So my known is now my water. You have to start with the limiting. That's why you have to do that step first. You cannot start with the excess. The limiting reactant limits you on how much product you make. So you have to start with the limiting. If you start with the excess, that's not a valid expression of what you're going to get out of this reaction. The limiting reactant limits you. You have to start with that. So we're still doing our mass to mass. So 1 mole of your known is on top. The bottom is the molar mass of the known. I think some of you were using the coefficients, so you were doing 4 times 18 grams. You do not do that. You only do 18 grams. The only place this coefficient is used is in the mole ratio, the second step. Okay, so my coefficients are 4 moles of my unknown over 4 moles of my known. That's the only place I use the coefficients. Do not use them to multiply for the molar mass. And then my unknown molar mass is about 2 grams, and then 1 mole on the bottom always. Okay, so now I'm using my limiting reactant to find how much product of unknown. Okay, so pop that in your calculator, and I get about 4 grams of H2. So I just solved for my unknown amount. So if I start with 36 grams of water in this reaction, which is my limiting, that is what's limiting this reaction, I will in turn, theoretically, should get 4 grams of hydrogen produced. Okay, so step 1 was determining limiting and excess. This is step 2, determining the theoretical yield of your unknown. There's a step 3, but we'll do that in the next video. Okay, so let's try this one from the start. Okay, so I'm going to put the question mark in just because that's what it would look like on a worksheet. Okay, so step 1 is to determine limiting and excess reactants. Now, obviously, you have to balance the equation first. So maybe if you want to do your stepping different, but balance it first or write it and then balance it. Then step 1, determine the limiting and excess. Okay, so copy this down, make sure you copy it correctly. Make sure you have the given numbers under the correct chemical symbols, and make sure you have the unknown under the correct symbol. Pay attention to that. Some of you were doing the work, but you had the wrong known or unknown, and that was completely ruining your problem. All right, so balance it, pause the video, come back. All right, so we're balancing. I got 2, 3, 2, 2. So I got to get oxygen right here even. To do that, that makes your life easier. All right, so I'll do both ways. You do whichever one you want. You can either start with CuS, copper sulfide, or you can start with oxygen. Whichever one you want, you're determining which is the limiting and which is the excess. So you're comparing these two. So go ahead, pause the video, work on that. And now is the only time I'm using my coefficients. I have O2, so I'm doing oxygen plus oxygen. I'm not taking it times that coefficient of 3. All right, so if you started with copper sulfide, you'll get about 7.5. It's okay if your rounding's a little bit different. Okay, and remember, this is what you need. You solve for what you need. If you did it the other way, if you started with oxygen, that's totally fine. Let me just flip-flop the numbers. Doesn't matter to me which one you start with as long as you pick a reactant. Ignore the product or products for right now. Okay, so no matter which way you did it, so if you started with oxygen and solved for copper sulfide, you would get about 30 grams. I'm rounding, that's fine. Okay, so remember, this is what we need. Let's compare to our given numbers, which is what we have. Okay, I need 7.5 grams of oxygen. I have 15. Think of it like money. I need $7.50. I have oxygen. Well, it appears that that is going to be in excess. I'll have some left over. By default, the other should be the limiting. If you compare it this way with the other version, I need 30 grams of copper sulfide. I only have 15. That's my limiting. Therefore, oxygen is my excess. You should get the same results. Okay, so that is step 1, determining the limiting and excess by just comparing the reactants. You should already know how to do that because you've already done it. All right, take it a step farther. Okay, so same problem, I already balanced it. We're saying that this is my excess. I'm going to cross it out. I just like to do that so I don't look at it. Okay, here's my unknown. So if you want to cross that out, go for it. Whatever's going to work best for you. Step 2 is to solve for unknown, specifically the mass. And if you want to jump ahead a tiny bit to our next lesson, that is called the theoretical yield. Did I spell theoretical wrong? Oh, I did. There's an E here. Theoretical. All right. Okay, so I'm going to look at my limiting. Start with that. Remember, you already have these numbers. No matter which way you do it, you already have the number. So don't resolve for molar mass when you already have it from the problem before. Okay, now my mole ratio is going to change because my unknown has changed. Only time I'm using my coefficients. And then my unknown's molar mass is 64-ish. Remember, I'm just doing S plus O plus O. I'm not taking that times the coefficient of 2. Okay, and if you plug that into your calculator, I get 10.04, I'm sorry, 10.04, or something close to that, grams unit label sulfur dioxide. That is my theoretical yield of product based on the equation. So if I started with 15 grams of copper sulfide, which is my limiting reactant, I theoretically should get about 10.04 grams of sulfur dioxide. Okay, so that's step 2. That's the worksheets on. We'll do step 3 next time.